So first I'm going to show you two examples actually. I sort of already did them, but I did a DC generator and I made a model of a switch reluctance motor. And I used the switch reluctance motor that we did as an example previously, but let me just start with the DC generator. I didn't have like a model of a specific DC generator. I just had a three-phase motor, and I just decided to use the three-phase motor because the back EMF is going to be three-phase, and basically what I set up was a rectifier circuit for it. I didn't put a smoothing capacitor, but you could put a smoothing capacitor so that it's more steady DC. So this is basically what the circuit looks like, and I'll show you how to set this up in ANSYS. But what you can do with this is once you can apply this like circuit to your model, so the excitations will be like external, and you'll import the netlist from this. And this is basically showing other stuff. So this is what the back EMF looks like, and then using the circuit you can analyze what the node voltage is using this like multimeter component in the circuit, and you can see that the rectifier is sort of only allowing like this to pass, sort of. And if you put a smoothing capacitor, it would probably be more constant. But the other example was this switch reluctance motor that we were doing as an example before. And I basically just set up this circuit where you can define a periodic pulse. So these pulses, I set them up based on what, like, I sort of first simulated it to see when I should switch the fields, and then based on that decided that it should switch from the W phase to the V phase to the U phase. And then if you watch the animation, you can see that the different phases are turning on at different times in order to produce torque. So basically what you do is, I already have this model set up, but if you go to your different phases or whatever you're using for excitation, if you change the type to external and then right click excitations, external circuit, edit external circuit, you can import the circuit that you make over here. So let me see if I really want to delete it, but here, if I just, so you can make a Maxwell circuit by going to the desktop tab and then clicking Maxwell and then Maxwell circuit, and then it'll make this new circuit here. And if you click on the right, there's a component library, and there's a lot of different components. So some simple ones like diodes and stuff. And let me see if I can grab it. So that's the diode model actually. So for certain components, you have to define a model for the component. So in this rectifier, I named the device diode, and I basically just said the threshold voltage and current were just really big so that it would act like as an ideal diode basically for this circuit. And once you have that named, device named diode, you can put in here name of model data reference. You put that name into the selection for when you double click this diode, and that'll apply the characteristics of this model to this diode. And it should place these three phases into the model initially. Let me see. I wonder if I can just copy this. Let me just make a copy of this so that I can delete it and redo it. So I'm going to delete this circuit in the copy. Let me make sure this is the copy. Okay. And in excitation, so make sure that, so if before I had this as like current and I had like a sine wave in here when I was running it as a motor, then if I change all the types of excitations to external, then if I right click excitations and hit external circuit, edit external circuit, oh wait, I think it still has, let me save it. Let me see. Yeah, so now that I deleted the external circuit that was already in this model, I can click create circuit. And then it'll make a circuit with the coils that you already have in your excitations in the model. And then you can build the circuit around that. So the way I built this circuit was, it's just a diode rectifier, and I put resistors here to represent like the resistance of the coils. And then when you like bridge stuff, you kind of just click on it and then click on the next one. That's basically it. I mean, you can find whatever components you need for whatever circuit you're trying to build in here. And if you're doing a switch reluctance motor, it should be pretty simple. You can just set it up like this with the 3 pulses going into the 3 phases. And then it kind of tells you like what the function looks like. It's just basically defining a step function, and you'll be defining like what time it goes high and how long it stays high for, and then what time it goes low. And then you can define the frequency of that, or you define the period of it. So like every second it'll go high at like 0.3 seconds and go low at 0.6 seconds or something like that. But depending on the RPM of your motor, that because you'll be running it synchronously, so depending on what speed your motor is rotating at, you'll have to decide when it'll switch, and based on the initial position of the rotor, you'll have to decide when it'll switch. And I think I was sort of setting up a model for a single phase induction motor as well, but if you're doing induction motors, it's a little bit more difficult, where you have to do the motion setup with the mechanical transient. And if you want to know more about that, you can ask me questions yourself individually, but I'm not going to cover that right now. But basically, that's all I had to say about circuits. It's not that difficult to set up. Oh, and I forgot how to tell you to actually import it. Sorry. So if you have this circuit, you can right click it and then export Netlist. And then I already have it saved as a generator rectifier, so I'm just going to replace it. And then if you right click Excitations, external circuit, edit external circuit, you can import circuit netlist and then find the netlist you exported, and then it'll import that. And then when you run the simulation, you'll have variables for whatever you have in the circuit. So I put this voltmeter and this ammeter in the circuit, so it'll be in branch current and node voltage is what these will be reading in the transient report. So if you have any more questions or you want to design a specific circuit for your project, you can ask me questions about that and I can help you guys right now. But besides that, I'm just going to open it back up to like office hours / project time.
Alex, since you have your plan is to design a DC generator rectifier, then why are you limiting yourself to three phase?
You don't have to.
Yeah, you can have
Yeah.
a very smooth one.
Yeah.
So that's a very good idea. I like that. That really helps
Yeah.
find a solution for. And then if you have that, your back EMF will go down.
Mm-hmm.
The smoother is,
Yeah.
the change will be less. The back EMF.
You're distributing it.
Yes. But that's a good idea. Thank you.
Yeah. All right.
Anybody? Because I checked most of you, I didn't see anybody working on a generator. Is anybody? You are? No. Yeah. Yeah. Yeah.
All right. Thanks.
Alex, we need.